Let's talk about position, velocity, and acceleration. So y equals to s of t, that is a position function. So what is a position function? Position function is we have an moving object. So when t is equals to a number, s is equals to a number. So that tells me, let's say when time is equals to 2, the position is 10. What that means is when time equals to 2, you tell me where you are. Once again, for position function, when time is equals to a number, you get a position. The position represents where you are. So at time equals to something, you tell me where you are. So in terms of a graph, when time is equals to a number, so let's say you have a parabola, x squared. When time is equals to 5, y is equals to 5 squared, which is 25. So when time is equals to 5, you have your position is 25. So it's a point on the curve, a location, a position. Just think about this is as a point on the curve. So you have a curve. When t is equals to a number, you tell me exactly where you are. And then y prime, so you take the derivative of the position function. You can call that a s prime of t, which is the derivative of s of t. We call that a vt. V stands for velocity, and then velocity of the function. So velocity is the first derivative of the position function, which is the rate of change of position. Okay, so the rate of change of position. Another way to write the velocity function is it can be dy dt, right, with respect to time, and then ds dt, the derivative of the position with respect to time. And then for the velocity, so for the velocity, the unit must be either like feet per second, feet per minute, meters per second, meters per minute, so on and so forth. So it must be meter, the distance divided by time. Again, for velocity, the unit must be distance divided by time, feet per second, feet per minute, meters per second, meters per minute. And then, based on the velocity, you take another derivative that leads you to acceleration. Okay, so that leads you to acceleration. So y double prime, so that is equals to s double prime of t equals to v prime of t. So based on the velocity, you take the derivative one more time. We call this at, and a stands for acceleration. So acceleration function is you use one function to describe the acceleration of a moving object. Velocity function is you use one function to describe the velocity of a moving object, and then there is a difference between velocity and speed. Speed is either 0 or positive, because look at the dashboard of your car. So either you look at the RPM or you look at the miles per hour. You see 0 miles per hour when your car is motionless. So when you step on the gas, it will go 20 miles per hour, 30 miles per hour. That is called speed. Speed is either 0 or positive. But for velocity, you have to define the position as well. Position, I should not say position, direction. So for velocity, direction matters. So if an object is moving to the left, the velocity is negative. An object moving to the right, the velocity is positive. So for velocity, direction matters. For speed, it's simple, either 0 or positive, just like the numbers on the dashboard of your car, the speed odometer. All right. And then acceleration is the rate of change of velocity. So here is one line to explain their relationship. So acceleration is the rate of change of velocity, and then velocity is the rate of change of position. So from position, you take a derivative, you get to velocity. Velocity, you take a derivative, you get to acceleration. And here is how I memorize this. So I will just start with a position function, and then for velocity, so that is f prime of t. Use whatever derivative method you like. That is at. You bring the 2 down, take the 2 minus 1. And then acceleration is s double prime of t. So you that is equals to a. This is a linear function, right? The slope is equals to a. And I always put position. I always put this position, velocity, and acceleration, because we are taking derivative, right? Take derivative means you bring the units down. So I will just go one line after another. So position, you bring something down to reach to velocity, bring the power down to reach to acceleration. And then what else can we say? Do we agree that this acceleration, so s double prime, is always positive for any t, right? For any t. What does that mean? That means the function s, the position function, is concave up for any t. In fact, the 4t squared is a parabola that looks like this. So this is always concave up for any t value. So that means if you take when t equals to a number, the position equals to a number, concave up. When t equals to a number, the position equals to a number, concave up. So it doesn't matter what point you pick, the graph is always concave up. So this is studying the acceleration using function. So sometimes the book or when you do works, they will just give you a table value. So table value can be one of the example for studying acceleration. So let's move this up. Let's move this up a little bit. So we have acceleration in a table value problem. So I have a table value, the time is in second, and then the velocity, so this time I gave you the velocity, I didn't give you position, is in feet per second. So when time is equals to 0, that's the velocity. When time is equals to 1, the velocity is 20 feet per second. Time equals to 2, the velocity is 34 feet per second. My question is, find the average velocity of the first 2 seconds. And then this one, you don't need to take any derivative because I gave you the velocity that is already the derivative of the position. Okay, so now let's do this. It's similar to average velocity, but this time we call this average acceleration. First 2 seconds, right? So let's break this down into 2 intervals from 0 to 1. So that is just v1 minus v0, just like the average velocity, and then time 1 minus time 0. And then that is 20 minus 0 divided by 1 minus 0, that is equals to 20 over 1. What's the unit? The top is velocity, so that is feet per second. I need you to write this down, feet per second. This is not optional. Feet per second, and then you take the fraction on top divided by the fraction on the bottom. So you multiply the reciprocal of the denominator. So this turns out this is 20 watch feet per second square, right? So you have feet per second multiply the reciprocal of the denominator. So that is feet over second square for acceleration. Yep. And then the other one from 1 to 2. So from 1 to 2, that is equals to v2 minus v1 divided by 2 minus 1. And then for 2, we have a 34 minus 20, that is equals to 14, right? And then that is a 14 divided by 1. What's the unit? The unit is feet per second divided by second. You will be handling this a lot when you take physics and engineering. So that is 14 feet per second what? Square. Alright, so that's it. That is a simple introduction to acceleration. If you like it, give me a like, share, and subscribe. I appreciate your help. I will see you all in the next one. Signing out.